Machine learning operations is a rapidly growing field that combines software engineering, data science, and DevOps practices to manage and deploy machine learning models at scale. In recent years, the need for machine learning operations has become increasingly apparent as more businesses seek to leverage the power of machine learning to predict outcomes, automate processes, and gain insights from data. Now, we will explore the role of machine learning operations in the responsible development and deployment of AI. To begin, let's define what we mean by responsible AI. Responsible AI refers to the ethical and transparent use of machine learning and artificial intelligence, with a focus on ensuring that these technologies do not cause harm to individuals, society, or the environment. Achieving this goal requires rigorous testing and validation of machine learning models to ensure they are accurate and reliable in their predictions. To make accurate predictions, machine learning models require large amounts of data, which must be processed and analyzed to extract meaningful insights. This process of data cleaning and pre-processing can be tedious and time-consuming, but it can be made more efficient through the use of machine learning operations, tools, and technologies. For example, open-source projects like Apache Airflow and Kubeflow provide tools for continuous integration and deployment of machine learning models, making it easier to process datasets and gather feedback from users. One of the most significant challenges in machine learning is the inherent risk of bias and error that can arise from the self-taught nature of these models. Machine learning algorithms learn from the data they are fed, and if this data is biased or incomplete, the resulting model may also be biased or inaccurate. To mitigate this risk, MLOps practitioners must ensure that the data used to train their models is diverse, representative, and unbiased. Another challenge that MLOps practitioners often face is the divergence between development and production environments. Machine learning models may work perfectly in a development setting but fail to perform in a real-world context due to differences in data or infrastructure. To address this, MLOps practitioners must establish clear guidelines and processes for testing and deploying models to ensure that they are robust and reliable in production. Additionally, in order to retain important information, it is crucial to create clear and concise documentation of the MLOP process. This documentation should include a detailed description of the steps involved in model development and deployment, as well as any reasoning or constraints considered during the process. Such documentation can serve as a fallback in case issues arise and can help MLOP's practitioners learn from past mistakes and continuously improve their processes. Another important consideration in MLOps is managing the life cycle of machine learning models. Like any software project, machine learning models evolve over time, and it is crucial to have processes in place to manage these changes. Continuous integration and deployment tools can help automate this process, ensuring that models remain up-to-date and reliable. In conclusion, MLOps play a vital role in the responsible development and deployment of AI. By incorporating best practices such as continuous integration, feedback gathering, and ethical guidelines, organizations can develop machine learning models that provide accurate predictions while minimizing the risk of unintended consequences. With a thoughtful and rigorous approach to MLOps, organizations can leverage the power of machine learning to drive real-world impact while maintaining high standards of accuracy and reliability.